some discussion on the topic how water is very essential or important in our day-to-day life. Okay, so today let us move on to the next topic of our discussion, and today we will discuss a very important thing or a very important phenomenon of water. Listen this topic very carefully. Okay, so that is the anomalous behavior of water. Anomalous behavior of water is very unique for water. Apart from other liquids, water got a very unique behavior or very unique property that is known as anomalous behavior or anomalous property. Okay, so before discussing that topic, I want to show you something that you might have also seen. If I will take a glass of water and I will add ice to it, then what you can observe? You can observe that ice is floating over water. Yes, can you see? This is a very common thing that most of the time you all might have observed, that whenever you will add ice to water, ice will float over water. But have you ever thought why this happens? Why ice floats over water? Ice is a solid. Ice is a solid form of water. So when we will add solid into a liquid, as solid is more heavier than liquid, it should go down. What will happen now if you will add a stone? It will go down. So as a solid, this ice should also go down water, but no, it is floating over water. This is only known as the anomalous behavior of water. Okay, so what is anomalous behavior of water? Before going to that, let me explain you some terms related to this topic. Do you know what is volume? Volume. So, what is volume? Volume is the area covered by an object. Okay, so if I will take this marker and I will place it over my hand, then you can see the area covered by this marker is known as its volume. Okay, and another term I want to discuss, density. What is density? Density means mass per unit volume. Okay, I am not going to that definition because gradually in your physics portion you will read more details about density. I will just simply define you the density. Density means how closely the particles are present. The more closely the particles are present, the more will be its density. The far apart it will present, the less will be its density. So don't worry, let me give you an example. Suppose here we have taken water. Here we have taken water somewhere, and when we will allow this water to cool, then what will happen? Have you ever observed when you will allow water to cool, then what will happen? See, this is the area of water, or now this is the volume of water. But when we will allow this water to cool, these all particles present inside water, they will come closer, isn't it? They will come closer and they will solidify into ice, so that the volume of water will decrease. Again I am repeating, when we will allow water to cool, the volume of water will decrease because of the surface area. See here, the area, this area is vast than the area of number 1. Here I am giving number 2. So when water will be in its liquid form, that time its volume will be more. But when we will solidify that water, all the particles, they will come together and they will be very close to each other, so that they will reduce their volume or their surface area will reduce. Okay. Similarly, when the water will be in its liquid form, then what about its density? Already I said, the more is the closeness of the particles, the more will be the density. Means here the density will be less and here the density will be more. Isn't it? Because here the particles are far apart from each other and here the particles before moving to the topic, I want to explain you the basic, then only I will move on to the topic. Okay, volume. Volume is the surface area covered by an object. Okay, so here if we will take water in its liquid form, then it has little bit wider surface area or it has more volume. But when we will allow that water to cool, the particles inside the water will come closer. Okay, when it will solidify, it is a general tendency of a liquid. Okay, so when we will solidify a liquid, all the particles of the liquid will come closer and they will solidify. Okay, we can take a simple example of water to ice. So here, when it solidifies or when we will allow it to cool, it will reduce its volume. Okay, the volume of water will reduce or the surface area of water will reduce. So what is happening to the particles? Here the particles are not so close to each other, but here when we will solidify as it converts, when we are reducing the temperature, the particles will come closer to each other so that when it will be in its liquid form, its density will be low because the particles will be apart from each other, and when we will solidify it, the particles will come closer to each other and its density will be more. The general definition of density is mass per unit volume. M by V is the formula. I am not going in details because I don't know in physics you have started this topic or not, but here in a simple way I am defining you what is density. If we will take density here, the more is the closeness of the particles, more will be the density. The less is the closeness of particles, the less will be the density. So can you tell me that if you will compare solid, liquid and gas, which one is having more density? Obviously solid, because solids have the particles which are very close to each other. Okay, then liquid and then to gas. So the density of solid will be more than to liquid and then to gas. Okay, now got it? What is area and what is density? Now let us discuss our topic, that is anomalous behavior. So anomalous behavior of water is a special tendency of water where if we will cool down water at room temperature, generally here we can write above 4 degrees Celsius. When we will cool water at room temperature, then its area or the volume will decrease and density will increase. Listen it carefully. When we will allow the water to cool at room temperature, means not a very low temperature, in moderate temperature, when we will allow water to cool at room temperature, its volume will decrease and density will increase, because when there will be less in volume, the particles will come closer to each other so that the density will increase. But when we will allow the same water to cool below 4 degrees Celsius, this is above 4 degrees Celsius at room temperature. But when we will allow the same water to cool down below 4 degrees Celsius, means its area or the volume will not change. Okay, means if we will allow this water to cool below 4 degrees Celsius, this is above 4 degrees Celsius. Okay, if we will allow it to cool above 4 degrees Celsius, or we can say if we will allow it to cool at room temperature, when we will allow it to cool at room temperature, it will reduce its volume and increase its density. But if we will take the same water and if we will allow it to cool below 4 degrees Celsius, then there will be no change in its volume, so that, or we can say there will be increase in its volume. Okay, slight increase in its volume. there will be slight increase in its volume, and when the volume will increase, obviously density will increase or decrease? Density will decrease. Got it? Again I am repeating. Here we have taken water. We have taken two conditions. One, at room temperature, we will allow this water to cool at room temperature, and again we will allow this water to cool below 4 degrees Celsius. So when we will allow water to cool at room temperature, its volume will decrease and density will increase. But when we will allow this water to cool below 4 degrees Celsius, its volume will increase. Okay, from its normal, the volume will little bit increase, and obviously when volume will increase means, see, if I will expand this pen or marker, anyhow it is a solid, I cannot expand it, but just I am giving you the example. Suppose take a rubber band. When we will expand it, means the particles inside the band will move apart from each other. Okay, and when again we will make it in its original position, means again the particles will come closer to each other. The same here I am giving the example. When water is in its original volume, this is the particles how they have arranged. But okay, let me show you the arrangement of particles like this. This is the arrangement of particles. Okay, when they are in its normal state, when we will allow it to cool at room temperature, the particles will come closer to each other so that they will reduce their volume, and when volume will reduce means density will increase. Here more is the distance between the particles means less will be the density. More the closeness of the particles means more will be the density. So here the density is more and here the density is less. Again, if you will take the example, when we will allow it to cool at 4 degrees Celsius, the volume will increase, so that when its volume will increase, then what will happen? The particles will again move apart from each other. Just now I have given the example of a rubber band. When we will allow a rubber band to, when we will stretch a rubber band means the particles inside the rubber bands will increase. Okay, so here just we have discussed about the spatial behavior of water. What is the spatial behavior of water? This is known as the anomalous property. So this is the anomalous behavior of water. So here we can say, apart from other liquids, here we are not talking about all other liquids, here we are talking about water. Water got a spatial property or spatial behavior. When we will cool down water at room temperature means when we will allow it to cool not at a very low temperature, we will allow it to cool at room temperature. At that time its volume will decrease and density will increase. But when we will allow it to cool below 4 degrees Celsius means its volume will increase and density will decrease. First of all, you all got get a clear idea about volume and density. That's why before starting this behavior of water, at first I have started the. So this is the anomalous behavior of water. Here we are not talking about all other liquids. Anomalous behavior is unique for water, remember. So what is anomalous behavior of water? When water is cooled down at room temperature, the volume of water will decrease and density will increase. But when we will cool water above 4 degrees, below 4 degrees Celsius, not at room temperature, when we will allow it to cool below 4 degrees Celsius, then its volume will increase and density will decrease. Okay, so this tendency, if you all have seen in very cold areas, then you might have seen sometimes if you all have visited any place, or in TV also, sometimes in Discovery channels you can see that in a ice surface above it, okay, but down all the aquatic organisms, they are not freezed, okay. Isn't it very interesting how the upper layer of water is ice, but down the layer they I mean the water body or the all the aquatic animals, they have not freezed, they are in their normal position. Because down the river, if you will down the lake, when we will see here, if you will take in cold countries, if this is the surface, okay, if this is the surface, then here due to increase in temperature, this is 4 degrees Celsius, 3 degrees Celsius, 1 degree Celsius, 0 degree Celsius, minus 1 degree Celsius, minus 2 degree Celsius, and so on. So here down we got 4 degrees Celsius, means all the water bodies, all the aquatic organisms, they will not freeze. As we will move up to the level of water, on the surface of water it got 0 degree Celsius, okay. Means when we will allow water here, as it is moving up gradually, the tendency of water will change. Means at the surface, when it will be at 0 degree Celsius, there will be ice, okay. You might have observed ice cubes, they are floating. You might have seen the picture Titanic, there you might have observed ice cubes, they are floating, okay. How it is floating? Because when the temperature is very low, that is below 4 degrees Celsius, at that time what will happen? The volume of water will increase and density of water will increase. But it is not same when it is at room temperature. When it will be in its room temperature, then what will happen? In room temperature, the volume will decrease and the density will increase, okay. So here we have talked about the anomalous behavior of water. This is a very important tendency of water, and here this feature or this tendency of water, only it is a very unique tendency of water. It is not with all other liquids, okay. Again I am repeating in short, what is anomalous behavior of water? When we will allow water to cool at room temperature, its volume will decrease and density will increase. When we will allow water to cool below 4 degrees Celsius, its volume will increase and density will decrease, okay. At room temperature, volume what? Decrease, density increase. Below 4 degrees Celsius, volume increase, density decrease, okay. Just opposite to each other, got it? So here this is below 4 degree, okay. So this is the anomalous behavior of water. That's why in cold countries, when there is extreme cold outside, then also inside water, all the plants and animals, aquatic plants and animals, they can able to survive because of the anomalous behavior of water, okay. So this is all about our today's discussion. So in our next discussion, we will move on to the next topic, that is the different sources of water. That will have some more discussion. Again go through this topic